So I'm asking us to find out when these two functions meet on a graph. There are two ways we could do this. We could sketch those two functions and see where that is. Is that a viable strategy? Is that a way of finding exactly where they meet? If we're really, really good with our graphing, yes, but we're dealing with rulers and all sorts of different things that could make that problematic. The crows disagree. Sorry, the crows agree. They think there's a better way to deal with it. So tell me, Harry, again, what happens at the points where these two functions meet. We're just looking at y equals 2x minus 3 and y equals negative x plus 5. What happens when they meet?
They collide.
Yeah? The coordinate should be the same, correct? So my y value for, let's just call this one function 1, and my y value for function 2, what should they be? The same or different? The same? What about the x value? If I draw a little graph here, and I've got two lines that intersect like so, at that point there, they've got the same y coordinate and the same x coordinate, correct? So realistically, y and x in both of those equations are interchangeable. Happy with that? Now, what does this symbol here mean, thanks, Hone? What does that symbol mean? Equals. I've never done maths before, I don't know why they gave me this class. What does equals mean to you? Never heard the word equals before. Describe it to me.
I always thought of it as equals.
Yeah, so what's that mean?
I don't know, it equals something.
Without using the defining word in the definition. Matt?
What the coordinate thing equal to the numbers?
Yeah. Paddy?
Both sides are the same.
Both sides are the same, correct? So I could interchange either one of those values. So what that means is you could use y or you could use 2x minus 3, correct? And the same here, I could use y or I could use negative x plus 5. So am I within my rights to the right? Negative x plus 5 is the same as 2x minus 3. Am I within my rights to do that? It's like I've substituted one of these equations into the other. Anywhere I see y, I write negative x plus 5 in the first equation. Now, how many things don't I know in this equation? Some of you are saying 2, some of you are saying 1.
Right.
It's definitely not 3. In that equation there, how many things don't I know, Pat? I don't know one thing, and that one thing is? So what do I need to find out what x is? I need to do something. I need to rearrange. I've got x's on both sides, what should I do? Ryan?
Get them to both x's on one side.
Get them to the same side. Which side should I take them to? This side? The right side? Why should I take them to the right side? Because I want to keep it positive, if I can. I could take them to that side, but it makes it negative and it's a little bit more tricky. So I'm going to plus x to both sides. What happens to the x's on the left? So now I'm left with 5 equals, what's 2x plus x? 3x minus 3. Braden, what do I do now? It's alright. What am I trying to do? What do I want to find out? What don't I know? So what do I want to do? I want to get it by itself? How do I get it by itself? I've got a times 3 and a minus 3. So what do I want to get rid of? How do I get rid of the minus 3, Dylan?
Plus 3.
Plus 3 to both sides. 3's on the right. Because I'm using reverse BIMDAS. So I do the subtraction, addition, multiplication, division. Now I've got 3x equals, And Hone, what's my next step?
That's when you divide by 3.
Very good. I divide both sides by 3.
Yeah.
And I'm left with some gross number 8 over 3, correct? If you were graphing, would you have found that? Probably not. It's pretty hard to find. That's going to be 2.66666 as a number, okay? Awesome. Pardon?
How do you think that's so quick?
Because, no, what's 6 over 3 is 2. So I know it's 2 point something. What's 2 over 3?
Sorry?
What's 2 divided by 3?
3 can't.
It was 0.6 or 60%, 666666 reoccurring. What's 1 over 3?
Can't. 30.
0.33333333. So 2 of that is 0.666666. Okay. Now I've asked to find out where these points meet. Do I know that yet? Why don't I know that yet? What do I know? I know the x value where they meet, but what don't I know? So what do I know about y? Do I know anything about y? I think I know 2 things about y. Dylan, what do you reckon I know about y?
Oh, that what?
What is y?
I don't know if it's right, but I reckon y. No, it's 2x minus 3.
I reckon you're right. Do you know x?
Yeah, it's.
So if I know what x is, and I know that y equals 2 of those minus 3, do I know what y is?
Yeah.
So can't I just go, I'm going to sub this into equation 1. Could I have subbed it into 2?
Yeah.
It'll be the same value, so I could sub it into 2. I might just do this over here so we can see. So I have to move the thing. So if I know that y, as Dylan said, so with equation 1, y equals 2x minus 3. I know x equals, let x equal 8 over 3. Happy with that? Y equals 2 times 8 over 3 minus 3, which equals 16 over 3 minus 3. How did I do that? So I'm going to show you very quickly. I did make a shortcut, and shortcuts are for those who know the way. Alright, what's 3 over 3? How can I make 3 as something over 3? Isn't 3 the same as saying 9 over 3?
Yeah.
The bases are now the same. What can I do?
You can.
Just take the top from the bottom, and I actually stuffed up because I made a shortcut. The answer is 7 over 3. So shortcuts are for those who know the way.
Wait, sir, how did you get the, what's that up top? No, like 2 times.
2 times 8.
Is that from the 2x?
Yep, 2x. So 2 times my x is 8 over 3
Yep.
minus 3.
Yep.
And now I've got a fraction. I don't have a calculator on me, so I need to get this the same. So I turn my 3 into 9 over 3.
Could we just put that to the calculator?
You could just have that in your calculator. And to be honest, I wouldn't want you getting caught up at this point here. It's not about this. It's about the simultaneous equation.
I agree.
But if we can work on our fraction, addition and subtraction while we're at it, 2 birds, 1 stone. So, that's my answer to question 1A. I'm going to give you a chance to work on question 1B. How will I be able to do question 2? So question 2 says here, I'm going to show you a little trick in a second. But question 2 says here, sketch the function to 1A to validate your findings. How will I do that? How will that sketching these functions help me? Connor?
It'll show you a rough area where they intersect.
And where would I want to see them intercepting?
Around 2023.
So I want to see them between the quarter, so they should be around 2 and 3 on both, but I'm hoping to see they intercept at 8, 3, 7, 3. If my line's relatively close. Sweet. So if your functions and your y and your x values are between 2 and 3, you're probably pretty close to the right solution here. Sweet. And you're just going to sketch those functions. Good man. Once we've done it by hand, I'll show us why we can do it a lot quicker on the calc or on another tool using Desmos. So let's get going on question 1B and then have a go at question 2.